Good day, viewers. In this virtual class, we're going to look at this integral before us. Integral, so integrate cos square x sine square s ds. Here we're going to use the techniques here by first of all looking at trigonometric identity. So we're going to find an expression that will be very convenient for us, to replace cos square x or sine square x. Okay, but if you recall that from our identity, cos x plus y is equal to cos x cos y minus sine x or sine y. If we decide that we are replacing s with y, that is, we're looking at the double angle, the sum of angle. If s is y, this automatically become cos x plus x. That will give us cos 2x. If I'm saying s is y, okay. Here, this become cos s cos y. This will give us cos square x sine x sine y. That will give us minus sine square x. And if we recall here that cos square x is equal to 1 minus sine square x. So if cos square x plus sine square x is equal to 1, so we can express cos square x as the subject of the formula. Similarly, sine square s is the same thing as 1 minus cos square x. Okay? And if in place of sine square s, in this place, in this expression, let me start. If we substitute in place of sine square x, this becomes cos 2x is equal to cos square x. Here, if we substitute this here, this becomes minus 1 plus cos square x. Because this minus sign will affect plus 1 become minus. The same minus here will affect minus cos square s become plus cos square s. Okay, so that's cos 2s is equal to cos square s plus cos square s. That will give us 2. That gives cos square x minus 1. We are trying to make cos square x, looking for an expression for cos square x. Okay, that means this will come this way. We'll have a 1 plus cos 2s is equal to 2 cos square x. To obtain cos square x, we divide both sides by 2. So the expression for cos square s is equal to 1 plus 2, 1 plus cos 2x divided by 2. So similarly, if we are trying to obtain an expression for sine square x, from here, we say that cos square s is equal to 1 minus sine square s. So that our sine square s will become 1 minus cos 2x divided by 2. So this is the expression for sine square s. By substituting in place of cos 1 minus sine square x, so that by the time you handle the algebra, this will be the expression for it. Okay, so we're going to substitute in place of cos square s sine square s. We have obtained an expression for it from this two expression here. So here we can now write that this is equal to integral of open bracket 1 plus cos 2x close bracket over 2, and open bracket 1 minus cos 2x close bracket the x. Okay, this is over 2. So here is a fraction. Here we bring out half times half. This becomes 1 over 4 integral 1 minus 1 plus cos 2x into 1 minus cos 2x or the x. Looking at this expression we have here is of difference of 2 squared. If we expand this expression, the result will become 1 minus cos square 2x ds. So the whole of this expression is now reduced. It's reduced to 1 minus cos square 2x. Okay, here we are trying to avoid this expression that carries square. So that means we can also express cos square 2x of this nature. So if that's happened, it means we are saying cos 2x plus 2x. This will give us a cos square 2x minus sine square 2x. Please just try to manage space there. So definitely this will become cos 4x is equals to 2 cos square 2x minus 1. The way we express, the way we're able to obtain this expression, so that's what will happen. But here, this is because this is 4, this is 2s, this becomes cos 4x. So here will be 2x. Okay, so that the cos square 2x is equals to 1 plus cos 4x divided by 2. So we look at our integral here. We replace this expression with this. So if that happens, this becomes integral. This is 1 over 4. Open bracket 1 minus open bracket 1 plus cos 4x divided by 2 ds. Okay, so the integral will affect everything here, so that our expression here, this become 1 over 4 integral of dx minus open bracket 1 plus cos 4x divided by 2 integral ds. So if we look at this integral here, dx, this is just this will give us 1 over 4 into, we integrate this one, it will give us x. Now we're going to integrate this. This one will give us minus x over 2. Here we're going to look at this. Okay, here is, if we integrate this, or we factor out this half x, factor this half, let's factor this half. This is minus 1 over 2. Okay, integral 1 plus cos 4x ds. So if we integrate x, we integrate 1, it will become x. Now let's find the integral of cos cos 4x. So if we integrate cos 4x, let's do it. Cos 4x. Here we use integration by algebra substitution by saying let u is equal to 4x, so that the u over the x is 4, so that the x, so the x here, the x is equal to the u over 4. So if we put it in this expression here, this become integral cos u times our ds is the u over 4. Okay, so we'll bring this out, 1 over 4 integral of cos u du. If we integrate cos, is the result is sine. So sine u, and u is 4x. So the integral of this, let's not go too far with that explanation. So the integral of what we have here, this is 1 over 4 into a large bracket. I have the x here minus 1 over 2. This become x plus 1 over 4 sine 4x plus a constant. Okay, we should also know that this 4 will going to affect the whole of this bracket because it's outside 6. Why these 2 will affect the whole of this bracket as well. So here become x over 4 minus, here we become x over 8, and here we become this time this is 8 times this is 32, minus 1 over 32 sine 4x plus an arbitrary constant. So we can also simplify this. This is 2. So here we become x over 8 minus 1 over 32 sine 4x plus c. So the integral of this expression is what we have on the board. Okay, that's what we have on the board. Okay, so all you should do in a situation like this, ensure you express them where they can be integrable. Okay, from there you carry out the necessary operation. Have a nice time. See you in my next virtual class.